Okay, we are now right on the edge of Sugarloaf Mountain, and actually this is the lower slopes of Sugarloaf Mountain right here. And these rocks are strongly bedded and still have a good cleavage to them. The easiest place to see that is in this chunk that's washed down here, where there is actually a foliation running this way and the bedding running this way at a high angle to each other. And you'll notice also that some of the layers stand out in relief. They stand up higher and some of them are sunk down lower. The reason for that will be obvious, which is why I brought along my little bit of acid here. And if I put acid, I think you can probably see that very easily in the camera. I brought along the strong acid just to make sure. These ones that stand up, no fizz. So that is siltstone in the darker layers that stand up with very little calcite in them. And that bit of light material that I put the acid on is mostly calcite. And some of this rock is somewhere in between. It is siltstone with some calcite in it, or very dirty marble with a little bit of silt in it, somewhere in between. This one right here is obviously mostly one or mostly the other, and it shows that conditions varied from time to time, from almost all silt with no calcite, and then mostly calcite when there was no sediment being washed in. So that's the evidence that this is shallow water deposits, that conditions of deposition are changing radically from one time to another, maybe from one day to the next. It could be each of those layers of silt could be a separate storm, washing material into whatever the body of water is. Body of water itself, as I say, nobody has ever reported fossils in these, or if they have, I haven't heard about it. And that's the only thing that could really give you a good date here. Now, the date they do have is a little bit better established than it is over where we just were on the slate quarry, because this particular sequence of rock here at Sugarloaf Mountain has a very nice sequence running from almost a pure quartz sandstone up into finer grained material, siltstone, and then into calcareous rock, into limestone. That is the original sequence of sedimentary rocks. Today, the quartz sandstone is a metamorphic quartzite. We're going to get to see that at our next stop when we go up the mountain. The silt has now developed a really good cleavage to it, a really good foliation, which indicates that they've got sheet silicates forming in there perpendicular to pressure. And the limestone is now a fine-grained marble. And what the geologists have done is make a guess, really just a guess, educated guess, that this sequence of rocks here is the same sequence of rocks that you see on the edge of the Blue Ridge, which is just a few miles away from here. Now it's separated by a fault again, and so that means you can't trace it directly and check that indeed it is the same rock. But there's a good chance that it is. And that rock on the Blue Ridge does have fossils in it, and you can get a good date on it. So if the guess is right that this is the same sequence of rocks here, just metamorphosed to get rid of all the fossils, then we can put a date on it. I've got a story on that though. And of course I went to school in Boston for my undergraduate degree. And when I was there in school, the Boston Basin was thought to be late Paleozoic in age, Pennsylvanian. And there was a report that a fossilized tree trunk had been reported in the rocks. I say it's been reported, it's a rumor. Nobody has ever seen that, if there ever was one. Now, then you cross over about 5 miles of igneous and metamorphic rock into the next basin over, which is the Narragansett Basin, extending from Rhode Island up into Massachusetts. And it is a very, very, very similar sequence of rocks. And that does have fossils. And that definitely is late Paleozoic. In fact, it's got coal beds in it. It's still fairly heavily metamorphosed, and so the coal, some of it's gone to graphite and doesn't burn very well. Matter of fact, so you could do lots of things with Rhode Island coal. The only thing it really wasn't good for was burning, which was sort of unfortunate. Anyway, about 10 years after I was at school there, they did manage to get some good radiometric dates on volcanic rocks in the Boston Basin. There's some rhyolites there. And they're interbedded with the sedimentary rocks, so you can take the date from the zircons and apply it to the sedimentary rocks. Since they're interbedded, they're about the same age. And it turns out those rocks are about 250 million years older than the rocks in the next basin to the south. So the fact that the sediments look very similar is just a coincidence. And the original date that I learned when I was in college turns out to be completely bogus, completely false. Therefore, when I say that these rocks are on the order of 500 million years old, because they're very similar to the rocks on the Blue Ridge a few miles away, I remember my Boston rocks, which were the same age because they were very similar and very close. Now, that doesn't mean that that date is wrong. It just means that if you accept that date as correct, remember that it is only a guess and that the evidence for it is not ironclad. Okay, and that's all we've got here. I'll leave that there for future reference next trip I take here.